Okay guys, so now I'm going to talk to you about how to find the domain of a function. You have three main types of functions that we're going to talk about. You have polynomials who you really don't have to do anything with. You just have to realize that their domains are unrestricted. So in other words, anything can be substituted for x and it won't cause a problem. Whereas with fractions, you don't ever want a zero denominator, so you have some restrictions there to your domain. And then with radicals, you don't ever want to end up with a negative underneath the radical, so there's some restrictions there. So the first skill is recognizing which case you have. So if you take a look at these four examples, this would be an example of a fraction, a function that has a fraction with x in the denominator, which we've talked about before, but we're going to go into more detail. So notice example 1 and example 2, they're both examples of fractions. Example 3 is an example of a radical. And example 4, notice there's no radical, no fraction. This would be a polynomial. So we're going to go through each. I'll just remind you of these rules. You can pause the video, copy them down, take a screenshot, whatever you'd like to do. But with fractions, we want to be mindful of a zero denominator. So our steps are going to involve that. And with radicals, we want to be mindful of a negative under a radical after everything is simplified. So let's take a look. So for the first example, again, we have a fraction, and we're focused on the denominator not equaling 0. So that's what we want to solve for. What would cause this to be 0? So you can kind of pretend this is an equal sign and just solve it like you normally would a quadratic equation. Okay, so notice this can be factored as the difference of two squares. So we'll go ahead and do that. X plus 3, x minus 3. Set each of these equal to 0 or not equal to 0. Get this by itself, and you have your two restrictions. So now let me just kind of show you what this looks like when we say x cannot equal -3 and x cannot equal +3. So what domain means is basically what are all the possible inputs for this function. What is everything that we can put in place of x? So this is basically saying you can put anything you want to in place of x, just not -3 or +3. So let me show you guys what that looks like on a number line. So here's -3, here's +3. We can essentially put the entire contents of the number line in for this function, just not these two values. So to express that in interval notation, you'll see it sometimes expressed this way, but then sometimes, and I think on my math lab, they're going to want you to express this in interval notation. So the way that you would write that is basically the domain can be anything from -infinity to -3, then skip over the -3 and anything from -3 to +3, skip over the +3 and anything from 3 to infinity. So yeah, so one of those two ways. My math lab will generally tell you whether they want it in interval notation or they will put the x and the not equal to sign if they want it in this format. Okay, so let's look at example 2. For example 2, same thing. We have a fraction. We don't want the denominator to be 0. Okay, now notice here this isn't factorable, so I'm just going to get x squared by itself. And if I went to take the square root of both sides, you can see a problem over here. I can't take the square root of a negative. So there's no solution to this inequality here, to this not equal to situation. So what that means is that there's no restriction. And anytime there's no restriction, then my domain is just -infinity to +infinity. So again, what that means is basically I can substitute anything I want to for x, and there's no cause for concern that this denominator is going to be 0, because anything we substitute for x could not possibly make this 0 since there's no solution to it being 0. I know that sounds a little backwards, but so that's what that means. Alright, so let's take a look at example 3. So example 3 is a square root, and again, we don't want the value underneath a radical being negative. So whereas with the fractions, we set it equal to 0 and solve and see what those solutions would be. With a radical, we're going to actually use an inequality. So if I don't want 5x minus 15 being negative, I'm going to set it greater than or equal to 0. Remember, think about the number line. Anything to the right of 0 or including 0 is going to not be negative. So we use this inequality for the radicals, and we solve for x. And when we solve for x, we get 5x is greater than or equal to 15. Divide both sides by 5, and we get x is greater than or equal to 3. So if I show you guys this on the number line, here's 3. 3 is included. And so my domain is going to be everything from 3 on. So it's a little different with the radicals because when you get it, it's more straightforward in that whatever you get becomes your domain. Whereas with the fractions, it's kind of more backwards. Like whatever you get is just, you know, with the fractions what we solved for were our exclusions, and we had to kind of think about our domain including everything else. Alright, so moving on. For example 4, we have this polynomial. Notice it's not a fraction, it's not a radical. So again, this is an example of a polynomial. Its domain is just negative infinity to infinity. There's nothing you can put in a polynomial where it's going to cause a problem. So just keep in mind, domain again means all the things that you can put in place of x. And so that is why we have some different ways of solving each type of problem that you get.